Okay, in 4.3 we're going to look at the multiplication rules for probability. Now, before you continue, be sure that you've seen all 500 of these videos from Miss Martin here. I did weed out a few of them. They're pretty short. Now, I'm going to skim through some of the rules here that I've pasted from her videos. The main thing here is this multiplication rule. Okay, so we're going to see it used a good bit in this lesson. And so if I have two independent events, and the thing is I want the probability of both occurring, then what I'm going to do is just basically multiply the two probabilities. Now let's look at a lot of examples. Now in all the examples that I'm going to look at with you here, I'm going to go sort of fast paced in the fact that I'm not really going to work them out. Okay, so what I'm going to do is just basically set up what the probability is, and especially on the multiplication rule, probably not multiply out the probabilities, but just leave that something that you can do in your calculator. It's pretty fast, and that's just the trivial part. So now in this example, we have two cards are drawn without replacement from a standard deck of 52 cards. So what is the probability of choosing a club for the second card drawn if the first card drawn without replacement was a club? So let's write this out in our notation here. So we're looking at, well, what's the probability that we draw a club here given that we've drawn a club first, okay, without replacement. So notice, most of these you can really do without looking at the complicated formulas, just by kind of using a little common sense. So notice, since we're not doing with replacement, if we draw a club first, so if the first card drawn without replacement was a club, well, that means one of the clubs is out of the deck. So let's think, in the deck of cards we have 13 clubs. Well, one of them was pulled, so that only leaves 12. And it's not 12 out of 52, but 12 out of 51, because we've already pulled one of the cards. Okay, let's look at another one now. This one says a box of 17 green, our box contains 17 green marbles and 6 white marbles. What is the probability of choosing a green marble if the first marble chosen without replacement was a green marble? That's very similar to the example that we just looked at. So we're looking at probability that we choose a green marble given that we first chose a green marble. So let's notice here we have a total of 23 marbles and 17 are green. But if it's given here that we've already chosen one green marble, then that only leaves me with 16. Now we have a total here, we have 17 and 6 would be 23 of 23 marbles, but if we've already pulled a green one without replacement, then that only leaves me with 22. And that of course will just reduce to 8 over 11. Okay, another probability question here where we're given one here. It says two cards are drawn without replacement from a standard deck of 52 cards. What is the probability of choosing a black card for the second card drawn if the first card drawn without replacement was a diamond? Now this one's a little bit different here. So again, we're looking at excuse me, the probability that we choose a black card given that the first card was chosen was a diamond. Okay, so notice if a diamond is chosen here, that really doesn't affect the number of black cards that we have. So we're still going to have 26 black cards. But now it does affect the total. If I've already pulled one without replacement, then that's only going to leave me with 51. Okay. Now on this one, again, you'll probably notice that I'm not really using the formulas. I'm using the notation, but I'm using more of a common sense idea than those formulas. So I kind of think that you would want to do the same thing in this lesson. Okay, so this one says, out of 450 applicants for a job, 202 are female and 56 female have a graduate degree. So what is the probability that a random chosen applicant has a graduate degree given that they are female? So we're looking at the probability that of pulling a graduate given that they are female. Okay, so we have 56 of the females are graduates here. But given that we're just choosing out of the females, then we're going to say that out of 202 and not all the applicants. So notice there again, I really didn't use any sort of formula. It was just more of a common sense thing. So I'm going to let you reduce that. I can't really figure that out quite yet there. Now, let's look at somewhere we're actually going to get to use the multiplication rule here. It says 2 cards are drawn without replacement from a standard deck of 52 cards. What is the probability of choosing a queen, then, without replacement, a king? And your answer is a fraction or decimal, and so I'm going to let you do that part. So what we have here is now we have these, not necessarily conditional probabilities, but the probability of 2 dependent events. So we're looking at the probability that we choose a queen and a king. So notice the and has a big effect on this. It's very unlikely here that we would do that with this word and. So remember, this is going to be the probability that we choose a queen, basically, times the probability that we choose a king. Now, what we have to understand, and I kind of left off some of the notation here, is that it's given without replacement. So these are kind of dependent probabilities here. So let's see, the probability that we choose a queen here, there are 4 queens in the deck, so that would be 4 out of 52 times. Now, really the way I should write this second one, the probability of a king given that we've already picked a queen. Okay, so I kind of leave that off usually. So the probability of a king given that we've already picked a queen there, because it does say without replacement, would be 4 out of 51 because we've already pulled 1 card out. And so now I'm going to let you guys just multiply that out. I'm not quite sure what that is. Okay, but you could just throw that in the calculator there. Okay, let's look at some similar questions here. So suppose you'd like to keep a jar of change on your desk. Currently the jar contains the following. I'm not going to read through this. What is the probability that you reach into the jar and randomly grab a nickel, then, without replacement, grab another nickel? There again, without replacement, so I'm not putting the nickel back, affects this probability. So they're not exactly the same. So now let's look at the probability of choosing a nickel. So let's say we have 17 nickels here out of, okay, let's see our total real quick here. So I'm just total these up. That would be 39, that would be 40, so that would be 79. Now I'm going to multiply it times the probability that we choose another nickel. Now we have to keep in mind that it's given that we've already pulled out one nickel, so that only leaves us with 16 nickels left, and we've pulled out again another nickel there, so it only leaves me with 78 total coins left in the jar. So we multiply this out here, and then that's going to give you your answer. Okay, another card problem, and this time it has 3, but the idea is that it's not really that different. What is the probability that the first card will be a club, the second card will be a black card, and the third card will be an ace? Okay, so let's see. What's the probability that our first card will be a club? So let's see, I think we have 13 clubs in a deck, so that would be 13 out of 52 times. Now, the second card will be a black card. Now, that's only going to leave me with 51. Now, let's think how many of them are black here. Well, half of them are black, so that would be 26. But if the first card was a club, club is a black card, then that would really only leave me with 25. And the third card will be an ace. Okay, so let's think how many aces are in there. Now we're assuming, I guess, that these weren't aces. Okay, that we would have 4, but now we've already pulled 2 cards, so that would just leave me with 50. So 4 out of 50 to pull an ace there. Okay, so we multiply those out. That'll give us our answer there. Now finally, this one's just really similar here. It says, what is the probability of choosing a club, and then without replacement, choosing a diamond? So again, the probability of choosing a club would be 13 out of 52. I'm going to say times. Now the probability of choosing a diamond, notice if we pull all the clubs out, or if we pulled a club out, it's not going to affect the amount of diamonds. So we still have 13 diamonds left, but we did pull a card, so that's only going to leave me with 51 there. I'll leave you for that to multiply out. I believe that's all.